And once again we wait for the beep. I've made some updates to my CPU virtual machine and its user interface. Now, the stack memory and the A register memory core dumps not only show the values, but they also show which character those values correspond to. The first 32 characters, 0 to 31, correspond to the ASCII control characters, and everything from 32 up to 255 corresponds to the extended Windows ASCII set. Anything from 256 onwards, we don't bother with. We just leave it as question marks. Now, you'll notice I've added some extra controls. I've spaced out the buttons for load program, single step, execute program, etc. The CPU safe mode's been moved down a little bit, and I've introduced controls for the machine cycle duration when executing the program, so you can make it run slowly at a more brisk pace, or flat out at 20 milliseconds. Now we'll load a program. This is my cat program. Unix programmers will be familiar with cat. It basically takes the input and sends it back to the output. Yeah. Basically takes an input stream and copies the data to a defined output stream. Usually with cat, both input and output streams are the terminal you're using, but these can be changed. Anyway, to move on, basically, decide where I'm going to put the code in memory, point the address register at the start of string, save that starting location, and then call a subroutine to get the length of the string. What that does down here is gets the current character and advances the string pointer in one instruction, checks to see if we've hit the 0 at the end of the string. If we haven't, loop back and repeat until we do hit a 0 and then return. Once we've done that, A will now point to the word immediately following the 0. So now what we do is we subtract the original string pointer from the address register to get the string length, transfer it to the X register, which is used as a counter. Now we repoint A at the start of the string, and the print loop outputs the character to the character stream, advances the pointer to the next character, and the DJNZ instruction, anyone familiar with Z80 code will know what that does. Decrement and jump if not 0. So basically what that does is subtract 1 from X. If X is not 0, loops back. If X equals 0, fall through to the next instruction, which in this case, halt the CPU. So we take that program, we load it in, stick it into the source code window, assemble it. Assembly, no errors, object code ready for loading. Load object code. And now what I'll do is I'll run it slowly with the CPU machine cycle duration of 1 second. That way, as you're watching it, you can pause the video and watch each instruction in turn. Let's run it. Obviously, this is going to take some time because it's taking 1 second per instruction, and it's got to run through quite a lot of instructions to complete the program run. But you're getting the idea. My virtual machine is running code. I've also managed to fix a minor bug in the assembler that whereby the assembler threw a wobbly if it encountered lines with appended comments in. That's now cured. And because you've been through all this punishment with this, we're now coming to the bit where it starts printing out the string. And as you can see, the output stream buffer is starting to fill with characters. Since I've made you endure the punishment of watching this execute at such a slow speed, I'll do another video and show you what it's like when it's at full speed. Though, of course, when it's at full speed, you won't actually be able to see the instructions operating individually. It'll all be a blur. Right, it's done, it's halted. I can now finish this video.